Now we do the same thing for f of 7. Okay, so for f of 7, we know that x is equal to 7. So we know that 7 is greater than or equal to 5. So since 7 is greater than or equal to 5, this is the f of x we'd use. So f of x would equal x squared plus 4. Okay. Does that make sense?
I have a question.
Sure.
So we will look for the numbers. If it's 3, that means it's less than 5. So we go to the equation that it will be less than 5.
Exactly.
If it's 7, we go by the equation it's like greater or equal to like 5.
Exactly. So whichever one would make this x true. So if you plug x into both of those, whichever one would be true would be the f of x you'd use.
Okay.
All right. Does that make sense? No. Okay. Any questions so far? All right. So we know here, since this is our f of x, f of 7 would equal 7 squared plus 4, which is 49 plus 4, which is 53. Let me kind of separate that a little bit. Okay, and we do the same thing for f of 0. So we know that here x is equal to 0. So which f of x will we use?
X plus 1.
Yep, we use the x plus 1 since 0 is less than 5. If you plugged it in here, 0 being greater than or equal to 5 wouldn't be true. So 0 is less than 5. So that means your f of x would be x plus 1. Oh, let me circle that one. Oh, sorry about that. Okay, so now to find our f of 0, that's just 0 plus 1, which is 1. Okay, and we do the same thing for our f of 5. Or in this case, x is equal to 5. Okay. Now for this one, you just look up and see wherever the equal to is. So this is the one you'd use, because if you plug it into both, this is the only one that would be true. Okay. So since 5 is greater than or equal to 5, so that means your f of x that you'd use for this one is x squared plus 4. So that means your f of 5 will equal 5 squared plus 4, or 25 plus 4,
29.
which is 29. Okay. So any questions on any of those? All right.
Do we gonna have the equation so we can plug in the numbers?
Yep, they'll give you the piecewise function, and they'll have everything given here. They'll give you all of that and just ask you which one is, what's the value of them. Okay. Now sometimes they'll give you the equation, sometimes they'll give you the graph and want the value there. So it's not as bad as you think. All right, anyone still writing this one? All right, looks like everyone's done. Oh, there we go. Okay, so let's say, for example, if you have the graph, that's your x and that's your y. Say from -2 to -1, 0, 1, 2, 3. I want to take it all the way to 4, so I'm going to make that a little bit longer. Okay, and let's say for our y-axis, we go to -1, -2, and up to 1 and 2. Okay, so let's say this part of the function, we take it all the way, that should be above the -1. And we get an open circle. Okay, let's say here we go from -1 with a closed circle all the way to 2. Let's say we pick back up on the other side of 2 and drop that down a little bit. And we take that all the way to 4 and close that circle. Okay. So in this case, we have 3 different functions all on one graph. And we want to use this graph to find f of 0, f of 3, and f of -1.
We have to find the equation.
Nope, you don't need the equation. All you need are the x values right there.
Oh, plug in the number.
Nope. If you have the x value, you just go either up or down and see where it, where it lies. Okay. So for A, f of 0 just means that x is equal to 0. So you just look at the graph and say, okay, where x is equal to 0, what's the value of y when x is equal to 0? Yep, so that value is -2. So f of 0 equals -2. Okay, which just says when x is equal to 0, y is equal to -2. Or f of x is equal to -2. Does that make sense? All right. And we do the same thing for B.
3.
Yep. So when x is equal to 3, what's the y value? Yep, 1. Because when x is equal to 3, you don't have anything down here, no graphs underneath it, but you do have a y value of 1. So f of 3 equals 1, which is just another way of saying when x equals 3, y equals 1. Or f of 3 equals 1. Okay. Any questions on that so far? All right, so we do the same thing for -1. And this is where the open and closed circle makes a difference. Because if you notice here, -1 has a value above and below it. But because of that closed circle, we know it doesn't include -1 up here. That's why you have the open circle. But it does include -1 here, so that's the value you'd actually have for -1. Does that make sense? Okay. So f of -1 would equal -2. So you're going to notice the closed circle. Uh-oh. when x equals -1, y equals -2, or f of x, or f of -1 equals -2.
Wait, I'm kind of confused as to how you're finding the functions
Sure, which
on
one?
the graph.
Oh, no
All
problem.
I see are lines right now, so.
Oh, no problem at all. This one, actually, let me draw like a little one next to it. Let's say if you have y equals 3, if you want to graph that, then that's just a straight line. So this is your xy axis. So if this is your 3 here, this is how the graph of y equals 3 will look. So in this case, your graph is y equals 2 all the way up to -1. And then on the other side of -1, your graph is y equals -2.
So are each of those lines like a different graph?
Yep, it's a different, each
function?
line is a different function, exactly. Yep, so you just have to figure out which one of those functions has a value over 3, or which one of those functions have a value at 0, which one of those functions have a value at, what was the other one, -1. So as soon as you find out which function has an actual value, now you can find your value there. Because this is just y equals 2, y equals -2, and y equals 1. Or f of x equals 2, -2, and 1. Does that make sense?
Yeah.
No, okay. Any other questions on this one? All right. Oh, bring that up a little bit in case anyone's still writing. Leave that. Actually, let me see if I can get well, can't get everything.
If you shut it all the light,
Hmm.
it's gonna work. We're gonna see everything.
Oh, every light?
All the light, if you shut it down.
Oh, it does?
Yeah.
Okay. Well, can you turn off both lights? We'll give it a try. Yep, just hit both bottom buttons.
No.
Yep, just the two bottom ones. There you go. Oh, almost. Yep, just the bottom. There you go. Thank you.
Look.
All right, now we'll see. Yeah, that's a little better. Does it look better?
Yeah.
Oh, okay. Necessity is the mother of invention.
My teacher in high school, she used to do that.
I think it's some sunny days it might work, and so today it works.
It's not enough.
I know. It may work today, but then it won't work Monday. But we'll just adjust it. All right. Let's let everyone finish up. It looks like everyone's done. Okay, so let's say for this example, find f of 2 for the piecewise function f of x equals -2x when x is less than 1, x plus 2 when x is between, that should be 1, not -1, x and 2, or x squared plus 2. You'll say 2 is less than or equal to x. This is the same as saying x is greater than or equal to 2. But sometimes in the problems, they'll switch them around. right, so just like before, you don't have to do this, but it sometimes helps you to visualize. Before, we only had 2 functions. With this one, we have 3 different functions. We have negative 2x, x plus 2, and x squared plus 2. Okay, so we can see that our x value break up at 1 and 2. So if we mark it from 1 and 2, we can see here that from x less than 1, our f of x equals negative 2x. Oops, clean that up just a little bit. And let me move that 1 out the way. Now when x is between negative, well, now I keep saying negative, between 1 and 2, so you have 1 is less than or equal to x, less than 2, then we know our f of x equals x plus 2. But when x is greater than or equal to 2, which is the same as saying 2 is less than or equal to x, we know our f of x is equal to x squared plus 2. Like I said, you don't have to draw this out, but if you're ever stuck, it helps to visualize it. So since we're looking for f of 2, we just have to figure out where does x fall into any of those. Okay, so we see here you have 2 functions that have a 2 for your x value. The only difference is this one is just less than 2. This one actually includes 2. So that less than or equal to makes a big difference when you're right at one of those points. Okay, so we know that if we plugged in 2 here, it wouldn't work. If we plugged in 2 here, it wouldn't work. This is the only one it would work for. That's why I was saying this is purely optional drawing this out, but it kind of helps you visualize it a little. Okay, so you have your x equal to 2. So x equals 2. So that means your f of x is equal to x squared plus 2. Does that make sense? All right. So since f of x is x squared plus 2, now we can plug in our f of 2, which is 2 squared plus 2. 2 squared is 4, 4 plus 2 is 6. Okay, so any questions on that one? Okay. Like I said, this is just to help you visualize. It helps to But if you want to just solve the problem, you could do that just looking at this part here. All right, leave that up for a few more seconds. Everyone's done. All right, so now we're going to look at the difference quotient. So if you think back to the slope of a graph, probably from geometry class. Okay. If you never had it, I'll kind of walk you through it. Okay, so you have the slope of a graph. Okay, so this is your x-axis, and that's your y-axis. See if you have a line right there. Probably could have made that a little bit lower since it's going past my points here, so I'll make that a little lower. There we go. Okay, so if you have this point here on the graph, we'll call that x number 1. And this point here on the graph, we'll call it at x number 2. Which means that if there's an x number 1 and x number 2, there would have to be a y number 1 and y number 2. And this one would be y number 2. Okay. So to find the slope, or the rate that the line will increase or decrease, we know the slope is equal to y2 minus y1 over x2 minus x1. Or in this case, the slope is represented by the letter m. Okay, so we're going to do the exact same thing, but we're going to kind of approach everything looking at it as a function instead of just x's and y's. Okay, so that means if you have the same graph, you have your x-axis and your y-axis. You have a point here, and you're going to pick any 2 points on that line. Okay, so let's say the point at the left, we'll call that x. Not x1, but just x. Okay, so let's say the point on the right, instead of calling it x2, we're going to call it x plus some number h. Think of it this way: if this would have been 3 and this one's 5, this would be 3 and this would be 3 plus 2. Or if you had 8 and 12, this would be 8, and this would be 8 plus 4. So you're just adding some unknown number to your x value. Okay, so that means if this is x, then this point on the x-axis would have to be some function of x. It would be y, but we're kind of using function notation only, so that's why it's just a little bit different. So that means here, if this is x plus h, then this point on the y-axis would be f of x plus h. Make sure that's... let me erase it and clean it up. There we go. Okay. Now we already have the formula for the slope. It's y2 minus y1 over x2 minus x1. But since we changed the notation up, it's f of x plus h minus f of x over x plus h minus x. Now, if you look at the denominator, x and minus x cancel each other out. Yep, because you have x minus x. Once you combine them, you just get 0. So this ends up being f of x plus h minus f of x over over h. And this is your difference quotient. Oops, sorry about that. Yes.
That's just a different way of writing the top of it.
Yep, a different way, just in form of a function. Okay. Now, for those of you who are taking calculus, this one formula would involve probably about 60% of Calc 1.
Calc 1 is more geometry.
In a way, but this goes more into the concept behind calculus, and it will
You teach
involve
calculus
this.
1 too?
I did last semester. I don't know about the fall. We'll have to kind of see if Calc 1 is left. They usually snatch that one up pretty quick. I don't know, that one's fun to teach to me, but everyone kind of likes it. Oh. All right, so we're going to use that formula to find the difference quotient for various functions. All right, leave that up for a few more seconds. All right, looks like everyone's done. Okay, so let's say, for example, I'm going to find the difference quotient for f of x equals x squared. Okay, so if you remember the formula, the difference quotient formula is f of x plus h minus f of x all over h. Okay, that means you need f of x plus h. You already have your f of x. So the first thing you want to do, find f of x plus h. Okay, so that means f of x plus h is just x plus h squared. Because remember, f of x is x squared, so f of x plus h is just whatever's in those parentheses squared. All we did was replace x plus h, well, x with x plus h. And then from there, you just FOIL it out, because that's just x plus h times x plus h.
Do we need to like put x squared plus h plus h squared or no?
Nope, just the x plus h squared just turns into x plus h times x
We
plus
don't
h.
need to, like,
Nope, if you just write it straight through there, you're okay. Okay, so if you FOIL it, that gives you x squared. Your outer is x times h. Your inner is x times h. And your last is h squared. And once you combine those two, you have x squared plus 2xh plus x plus h squared. Okay, so that's your f of x plus h. Now you already have your f of x,